All right, so we're going to do 5.9 homeworks for notes today, just to try and catch up from our break. So I'm on 5.9 homework. We're going to do some of these problems. 2 sine squared plus sine x equals 0. So when you're trying to solve the general solutions, there's basically two things you can do. So the two things that I'm going to say you should look out for are an identity that matches from the formula chart. So try to match it to a identity. And then if that doesn't work, then you can do some algebra steps. So by algebra steps, I mean you might find a GCF, you might do regular factoring, or you might just isolate the variable. All right, so let's start with number 1. If you try to match number 1 to anything on your formula chart, it really doesn't match anything. If you're thinking Pythagorean theorem, that's really not going to make it better. And generally when you match it, it's because you want to make it a simpler version of the original version. So there's nothing that would make this problem any simpler. So then let's go on to some algebra. If we look, I've got 2 sine squared x, and then I've got plus sine x. If you notice in both pieces, I say the word sine both times. That's called a greatest common factor. So I'm going to GCF out a sine x. So I write sine x outside the parentheses. And so now you kind of imagine distributing it back in. Sine x times what here gets you 2 sine squared. Well, you need the 2. That's how we're going to get the 2. And then we need a sine multiplies another sine is how we get the sine squared. Okay, and then we have to multiply something else. Don't forget you're representing 2 groups here, so you need to have 2 groups inside the parentheses. So you say, well, I have sine x multiplies times what here gets me plus sine x. Well, it's already there, but you still have to multiply something. So that number that you multiply by to get itself is 1. So we're going to have plus 1. Now, algebraically, the point of factoring, whether you're doing greatest common factor or whether you're doing regular factoring, the point of factoring is always to solve. So what we do to solve is we set each factor that you just found. So here's a factor, sine x, and we can set it equal to 0. And then you also have the factor 2 sine x plus 1, and we can set it equal to 0. So let's go ahead and do that. So in purple I'll have sine x equals 0. And I can solve for that. And then in green I have 2 sine x plus 1 equals 0. And I'll get my 2 answers from that. So x equals sine inverse of 0. We know that that's not really a triangle. That's going to be on the axis here and here. So that's 0 pi and pi. And then subtract 1. So I have 2 sine x equals negative 1. So sine x equals negative 1/2. So that happens here and here. 7 pi over 6 and negative pi over 6. And so those are going to be my general solutions. I've got the general solution. So these are your general solutions. X equals 0 pi plus or minus 2 pi n. X equals 1 pi plus or minus 2 pi n. X equals negative pi over 6 plus or minus 2 pi n. And 7 pi over 6 plus or minus 2 pi n. And those are our general solutions. All right. All right, so we're not going to do all of these problems, but we'll do number 2, and then we'll go on to the back page. So make sure you have all this down. Pause this video if you need to. We're going to go on to number 2. So in number 2, it reads cosine squared x minus 2 cosine x minus 3 equals 0. So while this may seem like it's pretty similar to number 1, there's actually one really, really big difference. It's not that it's cosine versus sine, it's that the difference is coming from this number right here. This -3 makes it a totally different problem than in number 1. In number 1, you just had sine squared, and then you had a sine, and that was it. But in number 2, so let me zoom into number 2. Number 2, we've got cosine squared, then we've got 2 cosine x, and then we have this lone number by itself. And it's that thing that's going to be a lot different. When you have a number all by itself like this with a squared and a regular term, this is regular type of factoring. If I relate it to actual factoring, it's like x squared minus 2x minus 3. You don't have greatest common factor because this 3 really messes up greatest common factor. But we do know how to do some regular factoring. So with trigs, we're going to do kind of easier types of factoring. You're just going to say, well, what multiplies to cosine squared? So that's, of course, cosine times cosine. And what multiplies to -3, yet will add to -2? So that's -3 and 1. So if you just want to check it really quickly, -3 times 1 is -3. -3 plus +1 does make that -2. All right, so once again, the point of factoring is to set the factors equal to 0. Well, here I end up with cosine inverse of 3. Well, 3 over 1 is not an adjacent over hypotenuse that we can draw. So this gets me no solution. Now let's come over to the second part. Cosine x plus 1 equals 0. So here I can draw this and it gets me the answer pi. So I've got x equals pi plus or minus 2 pi n, and that's our only solution here. So if y'all want to do number 3 really quickly, you can pause the video and then I'll show you what number 3 is. So we get sine x plus 2, sine x plus 3. Make sure you're choosing the correct multiplication to 6. A lot of people are tempted to choose 1 and 6, but if you're going to choose 1 and 6 to add to +5, it'd have to be -1 and +6. But the problem with -1 and +6 is when you multiply them, it's not +6. You need 2 and 3 because multiplied together get you +6, added together get you +5. And then hopefully from here you're able to finish. This has no solution. You can solve, you don't get a triangle from either example. All right, so we're on number 5, cosine 4x, cosine x plus sine 4x, sine x. So if we try to match it first, this matches to cosine, let me write it up here, cosine a minus b, where a is 4x and b is x. So 4x minus x, which is 3x. So from here, make sure you're doing the next correct step. This is cosine of 3x. That 3 is attached to the x. You can't get rid of the 3 first at all. It's attached to the x that's part of the angle. Instead, our next step here is to take inverse cosine on both sides. So I have 3x is now by itself, cosine inverse of -1. Now this is something I know how to evaluate. We've done this, and I get the answer of pi. So now I've got 3x equals pi plus or minus 2 pi n. And now final step would be to divide by 3. So I get x equals pi over 3 plus or minus 2 pi over 3 n. All right, number 6. So sine of pi over 2 minus x all over sine x. So this is going to be another matching. It's generally the ones that look really, really complicated that are going to match. This matches to your cofunction rule, and it makes cosine. So this is now cosine x on top, and then sine of x is going to stay on bottom exactly how it is. But now this cosine over sine is cotangent. So I can start solving, and when we solve, we realize or recall that cotangent's only going to have one answer. So I'm only going to find that one triangle in quadrant 2, such that negative root 3 is the adjacent over 1 is the opposite, gets me 5 pi over 6. Also, what's special about cotangent is not only does it only have one answer, but we are only going to add pi n instead of 2 pi n. All right, number 7 is another cofunction. So if you match that up to the cofunction, 90 minus theta, that's just the degree version of saying pi over 2 minus x. So don't let that trip you up. This is another cofunction. And number 8 will be the last one that we do here. So sine 2 theta, cosine 58. That's cosine 2 theta, sine 58. So once again, matching, we get to match to sine 2 theta plus 58 equals root 3 over 2. So from here, I can sine inverse both sides. So now I have 2 theta plus 58 equals sine inverse root 3 over 2. So this, I know how to solve and get two answers. I have 60 degrees as an answer, and 120 degrees as an answer. Now the problem is that I've still got 2 theta plus 58 on the left-hand side of the equation. So let's figure out how this is going to work. We're going to end up with 2 theta plus 58 equals, and let's do our first one, 60 plus or minus 360n, and 2 theta plus 58 equals 120 plus or minus 360n. So if I want to get theta by itself, I'll have to subtract 58. So now I have that makes 2. So 2 theta equals 2 plus or minus 360n. And over here, let's also subtract 58. So that makes 62. So 2 theta equals 62 plus or minus 360n. And then my final step will be to divide the side by 2 and here as well. So I end up, final answer, theta equals 1 plus or minus 180n and 31 plus or minus 180n.